Hey, everybody, and welcome. As I typically do with these two videos, is when something new comes out, I get a new piece of information I want to share it with you. And that's why I want to share this one, because this one is one that's near and dear to me. About 10 years ago, I had a mild concussion where I was actually playing racquetball, got hit in the forehead. And soon after that, I got blurred vision, ended up checking things out with the doctors, and said I had a partial retinal tear. And I went through a lot of different treatments, including some laser surgery to reduce my intraocular pressure. And it's been successful now. It said it would last about 4 years, and it's been successful for probably going on 10 or 11 years now. Recently, though, I went to an ophthalmologist in Atlanta who told me I still should treat the glaucoma, even though my intraocular pressure has been on the low side. The concern there was retinal damage and looking at inflammation of the retinal nerve. Now, because that was near and dear to me, and I'm always searching for something new, an article came out, which is actually going to be published December 12th, that talks about coenzyme Q10, one that maybe all of you are familiar with. Coenzyme 10 reducing oxidative stress in retinal tissue. Now, it's an interesting article. I'm going to share it with you. It gets really technical because it was done in animals where they actually induced retinal damage into these animals and wanted to check and see what it would do. Now, let me clarify a few terms first. Number one, reactive oxygen species. I remember when I first started studying natural medicine, because it really wasn't touched in traditional medicine, but reactive oxygen species say that certain tissues, when they begin sharing oxygen molecules, because typically of damage or injury, start to cause degradation. And the analysis that was given to me was actually a study that was done at, I think, Columbia University, that wanted to give us a good analysis of what this reactive oxygen species concept is. And they set up, I think, 200 or 300 dominoes. It's 200 or 300 mouse traps all over a field, I think the size of almost a tennis court. Then they went out and they took one tennis ball and threw it into that field, which jumped one of the mouse traps, which pushed it to another, which pushed it to another, and that ball bounced all the way through the entire field and set off about 90% of the mouse traps. The same kind of situation seems to happen in us. When a fuse is lit like that, where oxygenation takes place, where tissue gets damaged, a molecule of oxygen leaves the damaged tissue and goes to the next one, induces damage and moves to the next one and the next one. And you have this reactive, which means a cellular rusting of that tissue. Now, this is a really big problem if it takes place in your nerve endings. This is a problem that is very common in major issues like Parkinson's or Huntington's disease. Number two is superoxide dismutase. Superoxide dismutase is another way to measure the extent of that damage that's already taken place from the reactive oxygen species. So let me read this article as it is. Very interesting. It says coenzyme Q10 acts by scavenging reactive oxygen species. It gobbles them up and neutralizes them. And that helps to protect neuronal cells against oxidative stress, cellular rusting, in neurodegenerative diseases. We tested whether a diet supplement with COQ10 ameliorates oxidative stress. And here's another key word which you hear often, mitochondrial alteration, which means it went all the way down to the DNA and caused a compromise in the mitochondria, and the cell basically can die, not only from the reactive oxygen species, but the fact that it can no longer produce the energy it needs to survive. So they said they're hoping that this could as well promote retinal ganglion cell survival of those retinal cells in ischemic damage caused by interocular pressure elevation. Again, what I described to happen to me after that damage. A CoQ10 significantly promoted this survival, the retinal survival at 2 weeks after ischemia or the damage inducing. Superoxide dismutase and heme oxygenase expressions were significantly increased at 12 hours after the injury. So they verified that the two markers that they were going to say could be the markers of the significant part of that damage: superoxide dismutase 2, SOD2, and HO1, heme oxygenase, two markers that says there is this rusting taking place. CoQ10 significantly blocked activation of astroglial and microglial cells in the ischemic retina. So down to the DNA. I know this is getting really technical, but down to the DNA of that tissue and the nerve endings coming out of the retina were preserved. CoQ10 blocked apoptosis, which is cellular death, by decreasing, and it goes into what's called caspase-3 protein expression. Of interest, ischemic injury significantly increased mitochondrial transcription factor A, they call it TFAM-A, a protein expression at the retina which took place 12 hours after the inducement of the problem. Our findings demonstrate that CoQ10 protect the retinal neuronal cells against oxidative stress by modulating this BAX. Technical enough for you? Now, just so you know, when they did this, they went through a number of different ways to verify that this was actually something that was truly happening as related to the CoQ10. So they did this in mice. They did first the pharmacological treatment, and this is a crucial factor. Not all CoQ10 is created equal. So let's make sure we understand in this particular treatment, CoQ10 was purchased from Kanika Nutrients, based in Pasadena, Texas. Originally a Japanese company, the only true providers of raw material for CoQ10 in the world. It's a very expensive process. So true CoQ10 must say on the label somewhere, Kanika. Now, they went through this and they said they did whole mount immunohistochemical analysis. They did quantitative analysis. They did immunohistochemical analysis. They did Western blot, which is very similar to what they do in the initial stages of Lyme's disease. They did something called tunnel staining, measurements of DNA content, and then they went and they actually wanted to measure the CoQ10 compared to body weight of the various animals. Here's the discussion. CoQ10 is an attractive neurotherapeutic agent for retinal protection against high interocular pressure, elevation-induced oxidative stress, and retinal ischemic injury. Period. They call it a pharmacological treatment, a neurotherapeutic treatment. It has been reported that CoQ10 supplements correlated with plasma CoQ10 levels, and CoQ10 in large doses were taken up by all tissues, including your heart and your brain mitochondria, suggesting that CoQ10 could also be taken up by the retina and leads to a beneficial effect in ischemic retinal injury. On copies of this article, we have it, and it's from a journal called Apoptosis, which is cellular death. Now, it's interesting that this journal has become of high notoriety probably since 2014 with the dawn of Parkinson's disease and Huntington's disease and these really serious neuronal diseases really skyrocketing. Apoptosis is something that we want to avoid in our good cells. Apoptosis is something we want to induce in cancer cells. So just point of reference, CoQ10 is not usually used in cancer patients. Not that there's any side effects, but it's just not recommended. If you have other questions about this, about retinal control, about eye preps, and something you may be taking, and again, a high dose was used in here. As high as 400 milligrams twice a day would be the corollary to an adult. It's much higher than the normal 100 milligrams a day. So we were talking 800 milligrams to get the full effect of preserving the retina. Want more work on that? You want to talk about it? Give us a call at 678-228-8900. 678-228-8900. Our website is thenutritionshop.net. Please share this with others, especially if you know somebody's having retinal issues. God bless you, folks. See you back here soon. Take care.